Hi everyone, my name is Ziyi Ko. Today I will present our paper. Its name is Improved CAM with Auto-Adapted Segmentation and Co-supervised Augmentation. The object localization has been popular for many years. It aims to classify an image and localize the position of corresponding objects. But the traditional models usually require additional bounding box annotations, which means extra time and money. Besides, the annotations from different workers are not absolute enough. Therefore, more and more research has focused on weakly supervised object localization. It's a new task to classify the image and also identify the corresponding positions of objects without the bounding box annotations. Usually, they utilize the internal features to infer the positions of objects, such as the class activation map, self-produced guidance, and also a class peak response. Although there have been some work that try to enlarge and complement CAN, but firstly, they ignore the background parts in CAN, or they just segment the background by hyperparameters. And then the second one is they don't consider additional regularization for the generated CAN beyond the classification laws. Therefore, in this paper, we propose a new framework for weakly supervised object localization. It contains two novel modules. The first one is a confidence segmentation module that automatically determines the confidence area of CAN to then supervise additional CANs. The second one is a co-supervised augmentation module to add additional regularizations for the generated CAN beyond the traditional classification laws. The confidence segmentation module contains two parts. Firstly, it generates a confidence mask based on the original CAN. So the positive pixels in the mask indicates that the CAM is confident at that pixel, including both the foreground and background parts. Then this mask will be used to supervise additional CAM. Uh, the additional CAM will follow the previous one if the pixel is confident. Otherwise, it will try to be different. Based on the generated CAM, the co-supervised augmentation module will generate the foreground and background representations based on the CAM and the raw image. Then it designs different regularizations inside and across samples. For example, if two samples are in the same category, the DMN means the foreground representation should be as similar as possible. Otherwise, they should be different. We use these two datasets for evaluation because they are the commonly used ones for the task. We firstly evaluate our framework with localization error and classification error. We can say in both datasets, our framework with different backbones can usually have the best performance. Then we show the GT norm localization results, which means we don't care about the classification performance. We can also find that our framework have the best results. For the ablation study, firstly, we can observe that with two modules combined together, our model has the best performance. And then for the position to generate two cams, we found that the last block and the second last block in the VDG backbone can help us to generate the two best cams. The visualization demonstrates that the combined can usually have a better and precise results compared with each single CAN. Finally, we compare our results with SPG, and we can find that our framework can usually have a better performance. That's it. Thank you.